Dear students, I hope that you all will be fine by the grace of Almighty Allah. May Allah bestow you with good success in your studies. Dear students, in today's lecture, I am going to start a new chapter from your chemistry portion, which is titled here as Periodic Classification of Elements. This is the very first lecture of this chapter. So, our first topic that we are going to discuss in this very chapter, that is early attempts regarding the classification of elements. You are well aware that these elements nowadays they are arranged in a tabular chart, which is termed here as periodic table. So in the periodic table you find the elements in the groups, in the periods. We have a ready reference. Whenever we need the periodic table, we can keep it in our bag, in our hand, in our mobile. So we can have this facility now. Before this tabular form, the periodic table, before this modern periodic table, before this chart. So what were the early attempts? So what were the early scientists' attempts regarding the classification of elements? How these elements which are now arranged in the modern periodic table or in the periodic table, how these elements were earlier classified, how these elements were earlier arranged. Got it here? So in the topic we have to go through the early attempts regarding the classification of elements, how in the earlier times these elements were classified, who were the scientists, okay, how they utilized, we can say, their knowledge, their mind, huh? their energy to classify their elements. So our, we can say that in this lecture we are going to know about the early attempts regarding the classification of elements. So in our syllabus there is we can say the Dobryner's classification of elements. Dobryner was, we can say that he was an early scientist who gave his theory regarding the classification of elements. So in this lecture, we are going to learn about Dobryner's classification. Dear students, Dobryner's classification, which is also known as triads. In earlier attempts, elements they were classified on the basis of their, we can say, properties. So in earlier times these elements they were classified on the basis of their properties. All elements having similar properties they were put in a one group which was termed as family. Got it here? So in the earlier attempts, in the earlier times, scientists were trying to classify these elements. So they were classifying the elements on the basis of their properties, and they were, we can say that when they find that some elements have similar properties, they put them together in one group, and that group was termed as family. Dear students, in the year 1829, in this year, a German chemist which was named as, or whose name was Dobryner. Dear students, in 1829, a German chemist Dobryner he observed that certain elements had similar properties and that he could put them together in groups of three elements each. So Dobryner observed that some elements had similar properties and he put them together in the groups of three elements. In the groups of three elements means he formed the triad of these three elements. So these groups of elements they were called as triads. So then this Dobryner, a German chemist, he gave the law of triads. So according to Dobryner's law of triads, what it says that when elements are arranged in the order of increasing atomic masses, groups of three elements having similar chemical properties are obtained. So according to Dobryner's law, that if elements are arranged in the increasing atomic masses, if elements are arranged in the order of increasing atomic masses, we will get a group of three elements. Those three elements will be having the similar chemical properties. Okay, so we will get the group which is having the similar chemical properties. The atomic masses of the middle element of the triad being equal to the arithmetic mean of the atomic mass of the other two elements. That means that the atomic mass of the middle element will be equal to the mean mass of the, we can say, the first element and the third element. Got it here? So this was Dobryner's law of triads. I will repeat it. When elements are arranged in the order of increasing atomic masses, groups of three elements having similar chemical properties, they are obtained. Dear students, the atomic masses of the middle element of the triad being equal to the arithmetic mean of the atomic masses of the other two elements. It states that if elements are arranged in the order of increasing atomic masses, then we will get a group of three elements which are having the similar chemical properties, and moreover the atomic mass of the middle element will be equal to the mean mass of the atomic mass of the first and the third element. Now for example, there is one triad like lithium, sodium and potassium. Lithium having atomic mass 7, sodium having atomic mass 23 and potassium having atomic mass 39. That means the atomic mass of sodium, which is the middle element, will be equal to the atomic mass of the lithium and potassium, their mean atomic mass. Similarly, another triad is here: chlorine, bromine and iodine. Chlorine with atomic mass 35.5, bromine with atomic mass 80 and iodine with atomic mass 127. Here it also means that the bromine will be having the mean atomic mass of the chlorine and the iodine. Got it here? So this was, dear students, Dobryn's law of triads. Now, when Dobryn gave this law of triads, there were certain limitations, there were certain shortcomings of this law. And what were those, dear students? So limitations of Dobryn's law of triads were that it failed to arrange all the elements then known in the form of triads. So all those elements which were known at that time, Dobryn's law failed to classify them, to arrange them. Got it here? And dear students, only three triads were identified at that time. So this classification was not much successful. So we can here say these were the limitations of Dobryn's law of triads. And after that, some other attempts by different scientists came. We will inshallah learn about them in the next lecture. Till then, Allah Hafiz.